In this session, we'll run our first WaveQoE test. In a previous session, we set up the ports, the clients, the servers, and explained how the test maps the traffic against the clients in percentage. So now we will run our first test. So let's go back here and make sure we've set some reasonable short amount of test time. And we have, just as a reminder, a handset, laptop, and PDA. We've set up servers on the Ethernet side. We've set up traffic, each of which has its own SLA agreement set up, and the test itself has mapped the traffic against the clients in percentage, and we are asking for 25 megabits of total traffic, which will be accomplished with 12 handsets, 12 laptops, and 2 PDAs. So let's run the test. We see the console shows similar information than what we saw in Wave apps, where we're connecting up, validating the software. Now we'll be seeing the clients themselves get connected and get IP addresses. And since there are 26 of them, it'll take a little while to have all of those IP addresses handed out. And the test will run, and just as we did in Wave apps, there's a results directory where the configuration, the comma-separated data, and the PDF report will all be in that results directory at the end of the test. This is done in every Wave apps test and every WaveQoE test, so we end up having the ability to go analyze things in more depth or open up that configuration and rerun the test at a future date. Those configurations can also be used in Wave Automate. Now we see all the learning frames have gone, the TCP connections are attempted, so we're initiating all those TCP connections. Now remembering that we have VoIP traffic going on here, there will be SIP sessions that are set up as well. So here are all the SIP invites and OKs. Once the system is ARP through from all the clients, then the TCP sessions are set up, and now here we are running the test for 10 seconds. So all of that traffic will now be running for 10 seconds. If any of the clients did not connect or any of the flows did not connect, there is a variable that can be set up in the test that will allow for no failures at all or allow for a certain percentage of failures. Once the test is complete, all the connections are torn down and all of the statistics are drawn off of the cards, and now the report is generated. And remember, each one of the individual flows was measured against its SLA. So let's first take a look at the results summary. So here we see all the different types of flows that were defined in this test and what percentage of the traffic flows of each traffic type met their SLA. So if we are in a situation where we're interested about the QoS performance, we would like to see that voice and video gets prioritized over TCP and UDP traffic. And in this case, we see that TCP traffic, HTTP traffic failed, RTP video failed, but VoIP and link voice all succeeded. All of those flows met their SLAs is what the green means. Scrolling further down into the test, here is a summary table by flow type of the data that we saw. So here's packet loss, jitter, latency, the forwarding rate achieved, the intended load, and the offered load, right? So we see RTP video, we see FTP, the intended load was 1250, offered load then was 770. So that's around half there, right? So the file transfer time. So we can see at a glance the summary by traffic type. Another very interesting and useful view is this pie chart, which shows the intended load of 24 megabits, almost 25 megabits, what we set up, and what actually got offered and achieved on the network. So now you can see here that a larger percentage of RTP video, VoIP, link voice got their time on the air. which would infer that the prioritization is working correctly, and things like TCP and HTTP were less. So when the system was overloaded, there was some prioritization that took place. And then if we go further through the report, individual traffic types are analyzed, load values by traffic type, and it digs down into individual clients and individual flows. And the same thing is present in the comma separated files to give us a view of what happened on each one of the flows. So that's how WaveQoE is very unique. It gives us the ability that if we go back and think about all these different flows that were mapped onto the clients and then put onto the network, we now have detailed results against the service level agreement, right? The service level agreement by traffic type for how those individual flows performed. Now, from this point, there are a few advanced concepts that are worth talking about. One is if you want to begin doing some what if scenarios. Well, what if we change the client types? We remember that these handsets were all set up as legacy handsets. So one might ask the question, well, if we put 802.11n handsets in everyone's hands, would that be better? Would the increase in throughput that should come with 802.11n, does that really help things? Is this an issue of those legacy devices taking more time on the air than is needed? Another question you might ask yourself is, well, over the course of time, what if the mix of traffic upstream, downstream, and percentage of HTTP traffic versus video traffic, what if that changes? What does that do? All of these things can now be adjusted. You have a baseline of what your access point does. Now you can do some delta testing off that. Remember, this access point is an 802.11 AC access point, 3 spatial streams. So in raw throughput testing, we should be seeing 900 megabits of throughput, and we saw 450 megabits of throughput in earlier testing on this same access point. So this access point is not blistering fast, but notice that an access point that delivered us 450 megabits of TCP goodput delivered with a mix of traffic and a mix of clients only 15 megabits of total throughput before certain types of traffic began getting choked out. So this is a really important information when you're doing enterprise level evaluation of access points for what is your performance going to be, how many access points do you need, what's your deployment strategy really going to look like when you are running actual traffic and actual flows. It's very difficult to calculate ahead of time what you're going to see out of individual client types and what you're going to see out of individual flow types to figure out how much total throughput you're going to get. So again, you can make your adjustments to clients. Often what folks will do is say, oh gosh, in my enterprise, I'm going to have another type of handset that comes in. So some of them will be, gee, I should add another type of handset and map that client and maybe make that one 802.11n. Well, that'll be fine. You can now start adding different mixes of those clients and map the traffic against them and run the test again. The other thing that we'll talk about here is the concept of being able to run that mixture of traffic to a real client device is where agents come in. So the agent allows you to define an agent manager on the Ethernet card. And then once you've done that, you can define then an agent instance if you know the IP address of the laptop or the PDA or the smartphone that has Wave Agent running on it. Now you can map traffic to that agent and you can run a test to an actual client device. Furthermore, if you want to run some kind of an ecosystem test to say how well will a client device behave in the presence of a mixture of traffic, you can do an over-the-air test here by using the WaveBlade with clients connected up in order to create that background ecosystem of traffic add agents in and watch how well that client device interacts with the ecosystem of traffic. Right? So that's what we'll cover here. There was one other item I'll talk about in that is that there are times where you might like to do some searching for where the performance level comes from. That's what this linear search is created for. So for example, you wanted to know where the SLA failures began to occur. So back here, if we look at the report that we originally looked at here, we saw that we have SLA failures. So we know when we are asking for 25 megabits, we get these kind of failures. So you might want to go into the application and do a linear search from 10 megabits to that 25 megabits in 1 megabit steps, let's say. And so it will just repeat the test over and over again at different I loads, recalculating the load across the entire test application every time it runs a new iLoad setting, and giving you individual reports for each one of those loads. Now you can, over time, run some kind of a search test to find out what was the highest setting where all of the SLAs were met, those kinds of things. When I mentioned you could continue when flow admission control fails, and you can continue when client connections. So if you're running an extremely large test and there are certain flows or certain clients that you're okay if they did not get connected, and you want to move the test forward anyway, the test gives you the ability to accept certain percentage of failure of connections. Here we have percentage of allowed connection failures. So if you're going to run a very large test and you would like the test to proceed even if some of the clients did not get connected, you can set this connection failure up. And if you are okay with certain flows failing, you can continue the test with that. And that's a more advanced view of WaveQoE.